In this video, we'll continue applications of differentiation. This time round, instead of distance question, we'll be doing some volume question. Difficulties in volume question in general is usually the first few parts. The differentiation part is not the most difficult one. Actually, coming up with the function or coming out with the expression, it's harder than actual differentiation itself based on experience. So let's take a look at this question, NYJC 2013 prelim. A company manufactures container in the shape of a right cone. Looks like this. Each container is made from a thin flat sheet of metal in the shape of a sector of a circle with radius A, theta, radians as the angle. Then after that, what they do is they fold this, they join these two up, they will fold into this cone shape. Question now, express R in terms of A, theta, and pi. So your job is to express this, find this in terms of A, theta, and pi. Point to take note, there is no H here, even though you see H here, right? So it's probably unrelated. So your job is just to make use of this and find some kind of way to link it up to R. So I hope you remember your Sec 3 EMath sector formulas, because let's find some similarity between these two diagrams, meaning like what translate to what from diagram 1 to diagram 2. Let's take a look at A. This length A has now become here, the curve length, which makes sense because you're joining these two pieces up, right? And then this metal sheet from 2D, you will plop up to give you this, where this is A. So first step done, we found out that here translates to this. Second of all, any other item, you won't be able to see theta, right? Because theta would actually not be this. This is not theta because you're turning it from 2D to 3D. So this is not theta. However, one more length remains untouched, which is this red color one. This one, known as the arc length. Where does this appear in my diagram 2? Turns out this arc length here actually becomes a full circle here. So that's our golden ticket to solving question 1. Let's take a look. What is the arc length? Arc length is just radius times theta, right? A theta. Now this has become the circumference of the circle. So circumference in diagram 2 is actually equals to A theta. 2 pi R, right? Equals to A theta. So R is equals to A theta over 2 pi. Now I'm done for the first part. Working is very easy, but coming up with this plan is the difficult part. Next one, hence show that the volume of the container is given by this humongous function here. So the volume of cone is just 1/3 pi r square h, right? But however, take a look at the formula that they give you. The one they want you to show does not have any r or h inside. The only thing that's inside is theta. So now here you should know that you're supposed to change this r in terms of theta, which we already did in part 1, and then we substitute away the h in terms of theta as well. So let's go ahead and we already have the first one. The h is the problem now. How do we get rid of the h? First of all, express h in terms of r first, which we can because of this right angle triangle here. From this right angle triangle here, you can see that r square plus h square is equals to a square. And h square would be a square minus r square, and h will be square root a square minus r square. Squeeze this in here, squeeze this in here. You should get a clean volume function totally in terms of theta. Remember, a is just a constant, so it doesn't matter, it's just a number. So v is equals to 1/3 pi r square h, which is square root a square minus, you see r again, right? So I'm going to put this r inside here again. A theta over 2 pi square. Looks really confusing, but take a look at what they want you to show. They want you to have v square. So clearly we should square both sides, which should give us v square equals to 1/9 pi square. This thing becomes power 4. So it becomes a power 4, theta power 4, 2 power 4, pi power 4. This has been squared, so it simply becomes a square minus a square theta over 4 pi square. Sorry, miss out one square here. Clean it up. What will I get? I will get pi power 2 cancels off with this, and the outside will just become a power 4, theta power 4 over 9 times 16. 144 pi square. Multiply this by a square minus a square theta square over 4 pi square. Factorize out a square, put it outside, I will get a power 6. And this becomes 1, and this becomes 1 as well. Second of all, I will factorize out 1 over 4 pi square. This will give us 1 over 4 pi square, a6 theta 4, 144 pi square. The inside becomes 4 pi square minus the denominator is gone, so this is just, and this would just be a6 theta 4 over 576 pi power 4, 4 pi square minus theta square. Now the hard part is truly over, and you're only awarded with 2 marks. So usually the really tough questions or really tedious question, you end up with not so much marks because they don't want to penalize students for not knowing how to do. Because even with this, even if you don't know how to do this, you can continue, because in the third part, we're just going to use this. So let's go through the motion. Find in exact form the maximum volume of the container if the sector has a radius of 2 cm as theta varies. So in this case, this means that A, your radius of the sector of the circle is 2. So A is equals to 2. What does your equation become? V square would become A to the power of 6 over 576, right? 2 to the power of 6 over 576 simplifies to just 1 over 9. So that's good. 1 over 9 theta power 4 pi over power 4 4 pi square minus theta square. Now let's differentiate this implicitly. We will get 2v dv d theta is equals to, this one we have to use product rule because there's one item here and one item here. Differentiate this, I will get 1 over 9 4 over 9 theta cube over pi over 4. And then we differentiate this, so we hold this, plus, we hold this and we differentiate this, which will give us theta 4 over 9 pi 4. Differentiate this, just give us negative 2 theta. And then, because they want the volume of the container to be a maximum, so all you need to do is do dv d theta equals to 0, and we bring this to the left hand side, which will give us theta power 4 9 positive 2 theta, because I brought it over. This will give me 4 over 9 theta cube pi 4 pi square minus theta square. Now let's do some cleaning up. This is gone, this is gone. This will become 2 theta power 5 equals to 4 theta power 3. So 16 pi square theta power 3 minus 4 theta power 5. Bring this over, I will get 0 equals to 16 pi square theta cube minus 6 theta 5. Factorize out theta cube, I'll get 16 pi square minus 6 theta square. Since this is 2 items multiplied together, this means that theta cube is equal to 0, or 16 pi square minus 6 theta square equals to 0. This means theta equals to 0. This side, you will get 6 theta square equals to 16 pi square. Theta equals to square root of 16 pi square over 6 plus minus. And of course, we reject the negative because theta has to be a positive value. So theta would be 4 pi over root 6. And of course, to end it off, they don't really want beta, right? Yes, they do not want beta. They want maximum volume. So you have to push that beta back into your volume function. So this part is just grunt work. Feel free to just skip ahead if you don't want to see me just sub in. So I'm going to make use of this here. Subbing in theta equals to 4 pi over root 6. V square is equals to 1 over 9 power 4. 4 to the power of 4 would give me 256 over root 6. Power 4 would give me 36 over pi power 4. And this would be 4 pi square minus 16 pi square over 6. Simplifying this would give me, this is gone with this, 256 over, so 64 over 81, multiply by 4 pi square minus 8 over 3 pi square. This would give me 64 over 81, 4 over 3 pi square. Now, this is v square, so to find v, we've got to square root both sides, which should give me 8 over 9, 2 over root 3 pi. Cleaning this up would give me 16 over 9 root 3 pi. So that's it for question 1. Really long question. For the next question, let's take a chill pill and do this seemingly easy question after that really long question we have done in the previous 10 minutes. This question, they say, a curve has this equation, find dy dx. Whew, finally, something not too confusing. Find dy dx of this. So all we have to do here is just to differentiate this implicitly, right? So let's differentiate the left-hand side first. We will get 2, bring down the power, copy the content, power minus 1, multiply by the differentiation of the inside. Differentiating inside will give me 1 plus dy dx. And on the right hand side, to differentiate this, it will just be 4. Copy this, right? Because differentiating e to the power of xy would be copy and multiply by the differentiation of xy, right? So if we want to differentiate xy, we have to first, to differentiate this, we have to make use of product rule. We hold x, we differentiate y, plus we hold y, we differentiate x, which is just 1. So this would be the answer. So e xy times x dy dx plus y. So now I'll make dy dx the subject here. First of all, we will eliminate the 2 with the 4. Let's simplify this. X plus y plus x plus y dy dx equals to, this side we'll get 2exy x dy dx plus 2y e to the power of xy. So the content with dy dx will be moved to the left hand side, which will give me x plus y dy dx minus 2x exy dy dx equals to 2y exy minus x plus y. Factorize out dy dx and bring it to the denominator here would give me 2y exy minus x plus y over x plus y minus 2x exy. So we're done with the first part. Next part, given that the curve cuts the positive y-axis at point A, find the equation of the tangent at A. So taking a look at this function here, if this curve cuts the y-axis at point A, can we find out what is point A? Of course we can, because to cut the y-axis, this is letting x be 0. When x is equal to 0, this will become y squared equals to 4 e to the power of 0, which gives us 1. So y equals to plus minus 2. Why there are 2 answers is because the curve actually cuts the y-axis at 2 points. One of them is -2, one of them is 2. And because they say cuts the positive y-axis at A, so this is not A. In fact, this one is A, which is 0, 2. So let's put that in 0, 2. Find the equation of the tangent at A. Not too difficult because all you need to do is put this into our previous answer. We'll be able to find the gradient at this exact location where x is 0, y is 2, which should give us 4 times 1 minus 2 plus 0 minus 2 over 0 plus 2, which gives us 2 minus 2 times 0, so nothing, right? So this is just 0. So this will give me 2 over 2, 1. Gradient is 1. Find the equation of the tangent. Y equals to 1x plus c. This x will be 0. This y is 2. So c is 2. Y equals to x plus 2 is the answer for my second part. Third part, the tangent at A meets the curve at another point B. So this tangent is going to meet the curve again. So all you need to do is equate this tangent to the curve, which is, let me copy it down, x plus y squared equals to 4exy. So all you need to do is equate these two up. What would we get? We will get x plus 2 squared equals to 4e x plus 2. Now sadly, this is a transcendental equation, meaning you have a quadratic equation on the left and an exponential equation on the right. You can't really solve this by hand easily, and also the question didn't say you can't use GC, right? So of course, let's go back to the GC and we key in these two equations, one on the y1, one on y2. So once we've done that, all we need to do now is to sketch the curve. Now you realize the curve looks like this. The blue one is the one on the left, the quadratic equation, and the one on the right, it's the red color curve. All you need to do now is solve for the intersection, right? Intersect. And one of the answer is 0, 4. So x is 0. So x is 0 is a solution. Any other solution? Looks like there is one here. So let's go and find out. Intersect. Gonna move to the left hand side. Turns out the other answer is x equals to -2. What we do now is we put this back into our tangent curve to find out the coordinates that meets the curve at another point. Putting in 0 will give you y equals to 2, right? And putting in -2 will give you 0. This is the coordinate 0, 2. This is the coordinate -2, 0. This is already point A, 0, 2. This is already point A. So this is actually the other answer we want. -2, 0. So that's 3 marks. Final question. A closed cylinder is designed to contain a fixed volume P such that its external surface area is the minimum. Find the radius of the cylinder in terms of P. And now to find the curved surface area, you open up the cylinder, there will be 3 shapes, right? 2 circles and a rectangle sheet. Now this rectangle sheet, this horizontal length is actually the circumference, which is 2 pi r. And this is actually the height of the cylinder. So the answer here is 2 pi r h. So we run into this issue where surface area is expressed as 2 variables, r and h. So because here we don't know whether to do dA dr or do dA dh, right? So to eliminate this issue, your area will be clean if only you can substitute away the h and turn it into a r somehow. And of course, that comes from the first line of this statement. V equals to P, which is pi r square h. What is h? H is P over pi r square. This is your ticket to making A in terms of r entirely. So this will be 2 pi r square plus 2 pi r. What is h? P over pi r square. Simplifying this gives us this. Pi cancels off, r cancels off. So it's actually just 2p over r. And then we want the external surface to be a minimum, right? Now the A, the r equals to 0. Meaning the A, the r is equals to 4 pi r plus negative 2p over r squared. Equating this to 0 will give us 4 pi r equals to 2p over r squared. 4 pi r cubed equals to 2p. R cubed is equals to 2p over 4 pi. R will be cube root of p over 2 pi. Bringing this back to the question, find the radius of the cylinder in terms of p in cm. That's the answer. Of course, because this question is 5 marks, you have to make sure that this is indeed a minimum. This is indeed a minimum. And how do you show that? All you need to do is use second derivative test. If your dA dr is this, dA dr is this, then your d2a dr squared will be 4 pi plus 4p over r cubed. And then putting this back here, you will realize that this is actually a positive number. Therefore, A is a minimum at r equals to cube root p over 2